Okay, good morning, everyone. Good afternoon, good evening. So, today we're gonna finish our presentation. We started yesterday, but we didn't finish due to lack of time. So, let's get started. And I want to make a clarification about yesterday. I think some of you guys didn't get the real purpose of this presentation. The purpose is not to talk about vehicle networking. Actually, I just gave a definition of vehicle networking to introduce you to the real topic. That is, we focus on protocols used for these in-vehicle networking aspects. You get me, right? So that's it. We're not talking about the different topologies. We don't focus on the different topologies like bus topology. No, no, no. This is just uh, a detail about these protocols, right? So we want to highlight the features that, the new features that these protocols bring to the in-vehicle architecture of the vehicle in order to, how to say, in order to fix or to fix some challenges, right? In order to overcome some challenges in vehicle architecture, right? So that's it. We focus on the protocols used and their features, right? Not really on in-vehicle components networking, so that we can use Cisco to simulate or visualize the networks used in vehicle architecture. No, 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 no. It's not about using Cisco. I think yesterday someone asked me the question about which simulation software we can use to simulate the in-vehicle networks. No, actually, that's not the point. That's not the point. So that was my clarification. So let's move. So yesterday, sorry, we were at, okay, not here. No, wait. Okay, I think we stopped here. So what can we say about this comparison between standard Ethernet and the automotive Ethernet? We can see that the automotive Ethernet provides like significantly higher bandwidth compared to the traditional communication networks like CAN or LIN that we just saw yesterday. I mean at the beginning of our presentation, and that feature enables faster and more reliable data transmission. So that's really crucial for applications that require large amounts of data, such as high definition video streaming, or over-the-air updates that we also call OTA updates in autonomous vehicles. Sorry. So I think about the evolution of automotive Ethernet, we will skip that part. We want to make that video short. So next page. Okay. So advanced driver assistance systems, ADAS, right? So what is listed here are a few applications of automotive Ethernet, right? What about ADAS? So by the, I would say, by the data rate features we just saw, we can imagine that automotive Ethernet plays a vital role in the development of, how to say, of modern technologies, right? Such as advanced driver assistance systems, the ADAS. Right. So the Ethernet's high bandwidth and the low latency also enable the real-time communication, right? Like FlexRay protocol, as we saw it, because FlexRay protocol also allows a high bandwidth. So that's it. So various how to say ADAS components like cameras, radars, lidars, and ECUs. They can use these protocols, like they can use FlexRay, they can use also automotive Ethernet, since these two protocols allow them really high bandwidth, high grade data communication. So, okay. So next we have the how to say the connected car features that automotive Ethernet allows to. So automotive Ethernet also facilitates the connected car features, yeah, such as infotainment systems, telematics, and vehicle to everything, like we usually call V2X communications. Okay, so next. Okay, that's the important part right now. We'll tackle our practical example. So before we need to say something about it, that's it. So automotive Ethernet overcomes like many limitations of other serial bus protocols. Yeah, there are also many other technologies that are mandatory for automotive Ethernet. So we will see an example of one of them, and that's the topic on which we will have our hands-on demonstration of how the communication between two ECUs looks like through this protocol. So, sorry. Okay. Sorry, let me get rid of something. Mm, mm. Okay. So, our example here is the SOMEIP protocol. SOMEIP stands for Scalable Service-Oriented Middleware over IP. So that's the SOMEIP protocol, and this protocol provides service-oriented communication over a network that can be at least two ECUs connected in vehicle architecture, and where a service can be multiple events, methods, and fields. So that's how this communication looks like. First, we have two nodes at least, right? So a communication is established between at least two nodes or two ECUs, right? And one ECU can be the client while the other is the server. So why one is the client and the other one is the server? Let me explain it. So the one that is the client ECU or the client node, it's because it's the one requesting for information to the other ECU that possesses this information. And when that ECU possesses this information, this ECU or node is called the server, right? So we have the client that is requesting for the information, and we have the server that is providing the client with this information. So here is how this communication is established. First, communication, we can see the method call, right? So how it works. This client requests this information, and then the server send a response that contains the information requested by the client, right? And then we also have another aspect of the SOMEIP protocol communication, is that it's a publish-subscribe protocol, So we can see that here about the event callback, right? So the client subscribe to something, to a group of events that he wants to get, but actually it might not want all the events in that group, that event group, right? He might just want only one event inside, the information about this event, and then but in this protocol it needs to ask for the whole event group, right? And then later it itself extracts the specific events it needs. Okay, so we have the publish subscribe aspect, where the client subscribe to an event group, and the server that has this event group, the information about this event group, publish the whole event group, right? So that they can get to the client, and the client can extract the specific information it needs. And next one, we have the notification callback. I think it's the same process, this publish subscribe process. So right now, let's get to the sorry. Okay, so these are the definition. We talked about events, methods, and fields, right? So what's an event? So an event provides data that are sent cyclically or on change from the provider to the subscriber, right? So the provider is the server ECU or the server node, and the subscriber is the client. The subscriber is the one who needs this information, and the provider is the one who provides this information. So what's a method? A method provides the possibility to the subscriber to issue remote procedure calls, which are executed on provider side, right? So that's the same concept, right? So the subscriber, it just asks for it just asks for a method, and then the issue that has this method just provides the subscriber with that method, right? So fields are combinations of one or more of a notifier, which sends data on change from the provider to the subscribers, a getter, which can be called by the subscriber to sorry, to explicitly query the provider for the value, right? And we have a setter, which can be called by the subscriber when it wants to change the value on provider side. So the major difference between the notifier of a field and an event is that events are only sent on change, right? And the notifier of a field additionally sends the data directly after subscription. So that's it. So these are the main themes, the main terms that we'll be using when talking about the different aspects of the SOMEIP protocol. So yeah, okay. So next, sorry. Okay. Now we have a detailed map about how the communication is established in the SOMEIP protocol, right? So we have at the left side the server, that is, as I said, the ECU that processes the information that is requested by another ECU. So the client is the ECU that is requesting this information. So we need to mention an aspect of the SOMEIP protocol, is that it has a function that we call the SOMEIP SD. What does it stand for? SOMEIP SD stands for SOMEIP Service Discovery, right? So we just talk about services, right? So a service is like what the ECU provide. It's like the information that other ECUs need. So it's if they request an information, the server ECU is just providing them with a service, right? So you're asking for a service, and I give that service to you. So that's it. So this aspect is called the SOMEIP SD. That stands for SOMEIP SD. Sorry, for SOMEIP Service Discovery. And then we have the SOMEIP protocol itself, the world protocol, and then we have the TCP/IP stack, uh, which the SOMEIP protocol relies on. As we said, it's an Ethernet-based protocol, right? So Ethernet, we have the TCP/IP stack in that protocol. It's even the same for the standard Ethernet, right? So that's it. So how this communication is established between the server and the client. First, we have how to say, uh, we need to have the server that what the server will do. It will tell the other ECUs in the networks, sorry, that it has this kind of information, right? And it will tell them also that everything, if one of them needs this information, they should contact it, okay? So if another ECU requests, maybe needs this information for a process or something on its side, then it needs to contact the ECU that has this information, so that that ECU can provide the other ECU with that information. So that's called the SOMEIP SD, because it offers that service. And all ECUs have a multicast address. So this is a bit like networking. So it has they have a multicast address, right? So they can exchange all the information on this multicast address. It's like a bus, right? Where all the ECUs get can have the information that is broadcasted in this multicast route. And then if one ECU needs it, then it can extract this information and treat it at its side. So that's it. So the first move is from the server to the client, right? So the server offers the service. Then the next step is the TCP handshake. So this is how to say, this is done at the TCP IP stack, right? So we have the TCP connection handshake, where the client is sent a TCP SYN packet, and the server acknowledge of this, that it received this TCP SYN packet, right? And then the client he closed that TCP handshake connection, that he by sending also an an acknowledgement that he received the message of the server. And then we can start the communication between these two ECUs, right? So the client issue, as I said, the client issue requests an information from another issue that possesses it. So we talked about event group, right? An event, we just define an event. So to get an event, you, as a client that is requesting this event, it's mandatory for you in that protocol, right? It's mandatory for you to request for the whole event group, so that you can yourself extract the specific event that you need. So this is how this protocol works. So the client subscribe to an event group, and then the server that has this event group can send the whole information about this event group, the whole data, to it can send it back to the client issue, right? And then the rest of the communication, it's at the SOMEIP protocol itself. So the information is sent maybe via the UDP protocol or the TCP protocol, depending on the data load. So that's it. And then later we have the request response communication. We just define it too. In that the issue is also requesting another information, and the server ECU is sending back this response that contains the data that the client ECU requested. So it can be sent by the server ECU as UDP packet or TCP packet, or on the multicast event route, right? So that's it. So next, I think we will get to our practical example. Okay. So let me how to say? Let me show the different screen. Okay. Okay. So this screen, this screen. Yeah. Okay. I think you guys can see the difference the different windows here. So the windows at the left is the uh, it's a Windows machine, right? It's the Windows shell that we will use as our ECU server, right? And at the right side, we have an Ubuntu machine that we will use as our client ECU, right? So as we saw a few minutes, sorry. Okay. So as we saw a few minutes ago, okay, sorry for this delay. Okay, here. Okay, we will have a simulation of the SOMEIP protocol. We say that it's a, oh, sorry. It's a service-oriented protocol, right? So it's only there is only communication when a service is requested, right? So this is one aspect of this is one feature of this protocol. One of the benefits, because you know in a vehicle there is a huge load of data that is exchanged between different components of the vehicle to make it run smoothly and safely, right? So this SOMEIP protocol, by being service oriented, it helps a lot, because so that uh, not too much bandwidth is requested at the same time. So it reduces the workload of this protocol, so that any issue that needs to how to say, that needs to process any information or do a calculation or something, that can use it easily, right? And that can use the full potential of this protocol, right? So here, as I said, on the left side, we have our ECU server, and at the right side, we have our ECU client. So our ECU client is an Ubuntu machine. It's a Linux operating system, and here we have our Windows operating system. So we talk about multicast route, right? a multicast address, right? So the multicast address, what is it? It's where the SOMEIP service discovery protocol will act. So it's where the SOMEIP SD packets are sent. It's like a bus, right? A bus where each ECU can access, a bus that each ECU in the in-vehicle network can access, right? So let's establish this multicast route. Mm, let's start. So here I can see all the different addresses and all the different, here I have the IPv4 route table and then the IPv6 route table. Here we are interested in the IPv4 route table, right? And the IPv6 route table. But here we will only establish IPv4 route with this address. The following. Let me. Mm, okay. Sorry. Oh, let's see first the IP of it. Okay, we'll see the, because we're using how to say, a virtual machine, and this virtual machine, the Ubuntu one, it's actually the, how to say, uh Oracle VM. So we're using for this, yeah, Ethernet adapter, VirtualBox host only network. So in the nestat, it's what's the number of the interface, VirtualBox host only network. Okay, 22. Okay. Okay, then the, okay, here. Okay. So we just saw the interface 22. Okay. So we just add this interface here. Okay. So this is our multicast address, and this is our multicast address mask, and then here we have the gateway. So we will, okay, it's added. So how to see that? Is we just create a multicast route. We just run the netstat command again so that we can see here our multicast address has been created. Okay, so we'll do the same on at the, how to say, at the ECU client side. We will check for the this multicast address, or so we see that we don't have this address here, right? So we will also try to add this route to the table. So the address is yeah, we just, okay, 224, 225, 226, 234, right? Okay, and then we just, okay, but right before that, we need to, okay, sorry, I need to see which interface I'm going to use with the if config. Okay, Okay, so we're going to use this interface. Okay, and then use this interface here. Okay. Oh, sorry, it needs a certain privilege for that. Then I need to uh, run it as sudo. I don't know if you guys are using Linux operating system, but you should, because it's really important in the professional market. Yeah, it's really important because a lot of companies are using Linux. I don't know, but you should, if you're not using Linux, you should train a lot about it. So okay. Okay, then I run this let's start command again so that we can see, yeah, our multicast float is added, right? So right now we need to check that both of our ECUs have access to this multicast route. So I will try to send some packets from the client to the server, okay? And we will check if the packets are easily successfully accessed by both of our ECUs here. So okay. So here is the command, and this is the command for the Ubuntu system, and we also have the command for the Windows system. Okay, but here I need to add this, and then okay. So I will start here, and then we will see if the packet sent by the Windows machine can be seen by the Ubuntu machine, our client SEO here. Okay, so we can get the different packets sent. So we have the confirmation that our multicast routes has been added successfully. So right now, both of our ECUs uh, can access this bus that is our multicast address that we just added, our multicast route that we just added, right? So right now we will run the SOMEIP protocol, right? We will run our SOMEIP protocol, and we will see, we will acknowledge that, how to say, that aspect, that is, this protocol is service oriented. It's an service oriented protocol, as we say. So this is an important aspect that not all the protocols used have. So that's it. Let's run our sorry. So this is the comment. But before that, I did many configurations. So I don't know if you guys are interested in getting the source code of this protocol. I can give you the link so that you guys can. It's an open source code, so you don't have to pay. You can access it and you can download it if you guys are interested in reproducing the same practical example. So I run the protocol right now. Okay, so this is how we can see that this protocol is running, right? So this is the SOMEIP protocol. It's a SOMEIP protocol. So that's how it works. So right now, everything is established, right? Uh, everything is established. So we can see here some events. An event group has been registered, all right? and we can see the different events with their